MS Ramaya University of Applied Sciences.
Hello students, let us have a discussion on characteristics of a transistor in common base configuration. The aim of this experiment is to study the characteristics of a NPN transistor in common base configuration. Motivation to this experiment. All integrated circuits uses transistors inside it in different configuration based on application. Let us understand the theory behind the experiment before conducting it. A BJT is a 3-terminal, 2-junction semiconductor device in which the conduction is due to both the charge carriers. It is a bipolar device and it amplifies the sine waveform as they are transferred from input to output. BJT consists of 3 terminals: emitter, collector and base. In common base configuration, the base is made common to both the input and output. Input characteristics is a plot between VEB and IE with a constant VCB. To conduct this experiment, we need dual DC power supply, multimeters, resistors 1 kilo ohm and 10 kilo ohm, BJT either SL100 or CL100 or BC107, breadboard and connecting wires. Figure shows the circuit diagram of an NPN transistor used to study its characteristics in common base configuration. Figure shows the experimental setup and breadboard connections of NPN transistor in common base configuration. Experimental setup is made as per the circuit diagram. To plot the input characteristics, set VCB is equal to 1 volt. Vary DC power supply VBB in steps of 0.1 volt up to 1 volt and in steps of 0.5 volt up to 6 volt, and note down the corresponding VBE and IB readings. Set VCB is equal to 12 volts and repeat the above procedure. Plot the graph between VBE and IE for the two values of VCB. To plot the output characteristics, set IE is equal to 3 milliampere. Vary VCC in steps of 0.5 volt up to 10 volt and note down the corresponding VCB and IC readings. Set IE is equal to 6 milliampere and repeat the above procedure. Plot the graph between VCB and IC for the two values of IB. Figure shows the expected input characteristics for 3 different values of VCB. Figure shows the expected output characteristics for a number of different values of IE. Limitations of the experiment. Initially, some small current readings can't be observed by multimeter. For some value of current readings, multimeter takes some time to give an accurate value.
Hello students, name of the experiment is characteristics of a transistor in common base configuration, and aim of the experiment is to draw the input and output characteristics of a transistor in common base configuration. Components required for the experiments are 4 multimeters. In this experiment we are using 4 multimeters. Out of 4, 2 multimeters are used as a voltmeters. One is for input voltage, one is for output voltage, and another 2 multimeters are used as a ammeter, one is as a input ammeter, one is as a output side ammeter. Dual DC power supply, this is DC dual power supply, and here you are using both power supply for this experiment. One power supply is used to give a input side voltage and another side of the power supply is used to give a power supply to the output side of a circuit. Breadboard, this is breadboard, it is used to connect the different components of the given circuit. Connecting wire, these are connecting wires which are used to connect the different components on a breadboard. NPN transistor, this is a NPN transistor having a model number SL100, and it is a 3-terminal device. If you see on its body, one end is having a notch, there is a notch here. This terminal which is near to this notch is called ammeter, and after ammeter there is a terminal called base in a clockwise direction. After base there is a terminal called collector. Ammeter, base, collector. This is 1 kilo ohm resistor, its color code is brown, black, red. Let us start the circuit connection of a transistor in common base configuration based on the given circuit diagram. Let us start the circuit connection from input side voltage source. Let us take this as an input side voltage source and this as a output side voltage source. Based on the given circuit, the positive terminal of input side voltage source is connected to ground. Take a wire, connect to this positive terminal of voltage source and connect it to a ground line, and let us take this bottom first row as a ground line. So I am connecting this to a ground, and next a negative terminal of the input side voltage source, this point, take a wire and connect to this point, and which is connected to a resistor. To make a connection, connect this wire somewhere in a breadboard like this. So this point is connected to resistor one end. So take 1 kilo ohm resistor and connect to this point one end like this, and another end connect somewhere in a breadboard. So another end of the resistor is connected to the ammeter negative terminal. Let us take this multimeter as a ammeter, and it has two terminals, one is positive, one is negative. So based on circuit connection, negative terminal of this ammeter is connected to the resistor. So take a wire and connect to the negative terminal which is connected to resistor this end, and positive terminal of the ammeter is connected to the ammeter terminal of a transistor. To make a connection, I will connect this somewhere in a breadboard like this. So next take a transistor. So this is a SL100 transistor, as I mentioned, which has 3 terminals, ammeter, collector and base. A terminal which is near to this notch is called ammeter terminal. So based on the circuit connections or circuit diagram, this ammeter terminal of the transistor is connected to the positive terminal of ammeter. So I will connect in a breadboard like this, and the base of transistor is connected to the ground line. So as I told, this is a ground line, first row in the bottom portion. So I will connect base of a transistor to ground, and collector of a transistor is connected to some other port. So I will connect somewhere in a breadboard. We will do that connection later. Now, so we need to connect a one voltmeter. Let us take this voltmeter as a voltmeter first to make it off, and which has two terminals, again positive and negative. Red is positive, black is negative. So based on the circuit diagram, a negative of input side voltmeter is connected to the ammeter terminal of a transistor. So this is the ammeter terminal of transistor. I will connect this negative of the voltmeter to this terminal, and positive of voltmeter is connected to, take a one wire and connect to the positive terminal of the voltmeter, which is connected to a ground line. Connect to ground line, as I told, this so is a ground line. Connect to a ground line. So now we have connected one voltmeter at input side and one ammeter at input side. So make this as a voltmeter by using this knob. Keep it in a DC voltage mode. Let us keep it in a 2 or a 200 milli, and this multimeter I have configured as an ammeter, so I have to change its knob to DC ammeter range. Let us keep it in a 200 micro amps range. Now we will connect the circuit connection for output side. Based on circuit diagram, the collector terminal of transistor is connected to the ammeter for negative. So let us take this transistor as an ammeter. First make it off, and which has two terminal, one is positive, one is negative, that is red is positive and black is negative. So negative of this ammeter, take one wire and connect to the negative of this ammeter, is connected to a collector terminal of a transistor. So this is a collector terminal of transistor, connect here, and a positive of the ammeter is connected to a positive terminal of the output side voltage source here. So I won't connect directly, I will connect somewhere in the breadboard, some point. Then I will take one wire to connect this positive terminal of ammeter to the output side voltage source positive terminal. So this wire I will connect to the positive terminal of the voltage source, and negative terminal of the voltage source is connected to the ground. Take a wire, connect to the negative terminal of the voltage source, which is connected to ground. As I shown, this bottom portion of the breadboard, first row is a ground line. I will connect to the ground like this. Next we need to connect a one voltmeter at the output side. So make this meter first off. I will take one multimeter and I will make this as I will use this as a voltmeter. Again it has two terminal, one is positive red in color, one is negative which is black in color. So based on circuit connection, the positive terminal of the output side voltmeter is connected to the collector of a transistor. So this is the positive terminal of voltmeter, this is the collector. So I will do this connection, and negative terminal of the voltmeter is connected to, so take one wire, connect to the negative terminal of the voltmeter, which is connected to the ground. Now we have done circuit connection for a transistor in common base configuration, and as I mentioned, this meter we have used as a ammeter. So select it to a ammeter portion by using this knob, keep it in a DC ammeter range 200 micro, and as we have connected this multimeter as a voltmeter, select this multimeter in a voltmeter by using this knob, keep it in a voltmeter position. Let us take a 2 volt. This is input side voltmeter, input side ammeter, and this is output side ammeter, and this is output side voltmeter. This is a meter to measure a voltage VBE. This meter is to measure a current IE. This meter is to measure a current IC. This meter is to measure a voltage VBC. So first we will start with the input characteristics. To take a input characteristic readings, first we have to set VBC as 1 volt. So to set this as 1 volt, we have to turn on the DC dual power supply. Before turning on the DC dual power supply, set current value as to maximum and voltage to a minimum value for both source. Then turn on the power supply. My aim is to make VBC as 1 volt. To set VBC 1 volt, I have to vary output side voltage source. So I will vary this output side voltage source such that we will get a VBC of 1 volt. Now it's a VBC is coming almost as 1 volt. So now we have set VBC as 1 volt by using VCC. This is a VCC voltage source. Once you set a VBC as 1 volt, don't touch the VCC and don't check for the VBC. Now come towards input side. This is the voltage called VEE voltage, and this voltage is called VBE voltage. This current is called IE current. Now we will vary VEE value from 0 in terms of 0.1 volt up to 1 volt, and we will note down corresponding reading for VBE and IE. After 1 volt, we will increase this VEE voltage in terms of 0.5 volt up to 6 volt, and we will note down the corresponding reading. For example, if VEE is 0.1 volt, where VE as 0.1 volt by using this knob, I am getting a VBE of 0.144 volts and IE as 0.1 microamps. If you make it 0.2 volt, now we are getting a VBE as 0.2 volts and IE as 0.2 microamps. So we will vary this in terms of 0.1 volt up to 1 volt, and after 1 volt vary in terms of 0.5 volt up to 6 volt, and note down the corresponding reading for VBE and IE and tabulate these readings in a given tabular column. Once we have finished with all the readings for a VCB 1 volt, so now we should repeat the same once again for a VCB of 10 volt. To make that, first to make all voltage to 0, and now we will set VCB or VBC as 10 volt by using output side voltage source. So I will increase this so that I can get a 10 volt here. So I am getting a 1. Whenever any multimeter becomes 1, that indicates that its range has been finished. Go to next position, just shift the knob. So I need a 10 volts, just goes on, increase this voltage source till this multimeter readings become 10 volt. Now we have set VBC as a 10 volt. Once you set VBC as 10 volt, don't touch this VCC and VBC. Next come to input side. So again we will take the reading for VBE IE by varying VEE, that is in terms of 0.1 volt up to 1 volt, in terms of 0.5 volt from 1 volt to 6 volt as we took for a last time. So for example, if I make VE as 0.1 volt, I am getting if I make VE as 0.1 volt, I am getting a VB of 0.123 volts and IE as 0.1 micro. Now vary this in terms of 0.1 up to 1 volt, after 1 volt vary in terms of 0.5 up to 6 volt. Note down corresponding values of V, B and IE and tabulate in a given tabular column. By this we have finished input characteristics readings. Now we will start to take a reading for output characteristic. So first of all you have to make voltages 0. So to take output characteristic reading, first we have to set IE, that is the input current, as 3 milliamps. By using input side voltage source, I will set this as 3 milliamps. So it's going out of range, so I will shift its knob. Now it's showing a 0.7, so just increase it. So I need a 3 milliamp. Again it's going out of range, I will go to one more shift. So now I have set IE, that is the input current, as 3 milliamps. Once you set the input current as 3 milliamps, don't vary the voltage, input side voltage, so that is VE. Now come to the output side. So this is the output side current and this is the output side voltage. Keep that voltage in a minimum mode and current in a minimum mode. Now we will vary this output side voltage, that is VCC, in terms of 0.1 volt from 0 volts to 1 volt, and after 1 volt we vary this value in terms of 0.5 volt up to 6 volt. For example, if I make a VCC as 0.1 volt by using this knob, the corresponding current, that is IC, is showing out of range, so I will shift this meter range. Again it is showing out of range, we will go to the next range, it is giving a value of 3.46 milliamps and a voltage is coming around 0.082 volts. We will note these readings in a given tabular column. Next, increase this VCC, make it as 0.2, note down the corresponding reading for IC and VBC. So on, just continue to take a readings by varying the VCC in terms of 0.1 volt up to 1 volt, after 1 volt vary in terms of 0.5 up to 6 volt. Note down all readings in a given tabular column. Once we have took all readings for input current of 3 milliamps, now make all voltage as 0, and now we have to set input current as 6 milliamps. So by using this voltage V, that is the input side voltage source, I will set this input current as 6 milliamps. I will increase this voltage source. Now the input current is coming almost 6 milliamps. Once you set the input current as 6 milliamps, don't touch the input side voltage and input side ammeter and voltmeters. Now come to the output side, and here again you vary this output side voltage, that is VCC, in terms of 0.1 volt up to 1 volt, in terms of 0.5 volt from 1 volt to 6 volt. Note down corresponding current, that is collector current and VBC voltage readings. For example, if you make VCC as 0.1 volt, and you are getting a current of 6.02 milliamps and voltage of 0.071 volts. Note down these readings in a given tabular column and vary this voltage, that is output side voltage, which is VCC, like this up to 1 volt, that is in terms of 0.1 up to 1 volt, and in terms of 0.5 from 1 volt to 6 volt. Note down the corresponding IC and VBC in a given tabular column. So by this we have finished the output characteristics of a common base transistor. Now we have finished the circuit connection of a transistor in common base configuration. There we have took almost 4 set of readings, that is 2 sets of reading for a input characteristic and another 2 sets of reading for a output characteristic. Based on these readings, we will plot a characteristic for a transistor in common base configuration for input as well as for output. By this we are done with the experiment common base configuration of a transistor.
At MSR UAS, we spark your imagination unlike any other.